homogeneous differential equations and heterogeneous differential equations. We are talking about the ordinary differential equations. This can be split into homogeneous and non-homogeneous. Homogeneous differential equation is the type of differential equation where the terms involving the dependent variable. So let me first of all introduce what do you mean by dependent and independent variable. Suppose y is equal to f of x means based on x, y varies. So y is dependent variable and x is independent variable. So in this case, the dependent variables and its derivatives are all of the same degree. We consider like this, and this can be written in this form, that is dy by dx plus p of x of y is equal to 0, where the p of x is the function of x only. So in the case of second order homogeneous differential equation, it can be in this form, that is a of x. Second order differentiation can be written as a d squared y divided by dx squared, and that can also be represented by y double prime. And similarly, b of x of y prime plus c of x of y, that is equal to 0. So y double prime, that indicates what? That is d squared y divided by dx squared. What about this y prime? dy by dx, and this is the non-differential form, that is just y, that's all. Okay, so these two are differential whereas this is non-differential. Now here this is equal to 0, and you should try to understand this a of x, then b of x, then c of x. These are all the functions of x only. And what about this y double prime, y single prime? They are the second order derivatives. Y prime is the first order derivative of y with respect to x respectively. Do you understand this? Right. Now let me explain about the methods of solving the homogeneous differential equation. And before that, I would like to explain what is non-homogeneous differential equation. Let me consider dy by dx plus p of x of y, that is equal to q of x. So here p of x and the q of x are the functions of x only. Here it is not equal to 0. The q of x is not equal to 0. So non-homogeneous differential equations has non-zero term on the RHS. In the case of 0, that is when RHS is equal to 0, it is called homogeneous. When it is not equal to 0, that is when q of x is not equal to 0, means it is there. So it is non-homogeneous equation. And its orders, equation can be represented in this way: dy by dx plus a p of x into y, that is equal to q of x, because q of x is not equal to 0. So you have to remember this. Now let me talk about the solution, that is how to solve the homogeneous equation where the RHS is equal to 0. Do you understand? Right. Now let me proceed with this. How to solve the homogeneous differential equation. Okay. There are various methods of solving homogeneous differential equations. The separation of variables, solving homogeneous differential equations. First method is separation of variable. You can separate the variables. Okay, so this method involves the separation of variables on both sides of the equation, and then you can integrate it. Then second method is the method of undetermined coefficients. So here this method is employed for second order linear homogeneous differential equations where you have some constant coefficients. Then third one is the method of variation of parameters. In this method, we will employ the second order linear homogeneous differential equations with non-constant coefficients. And the fourth method is Laplace transform. Laplace transform. So here we used to transform the differential equation into an algebraic equation, and then it is solved, then transformed back to the original domain. Then fifth one, power series method. This method involves expressing the solution as a power series and finding the coefficients of the series. So the choice of the method depends on the specific form of differential equation and the boundary or initial conditions provided. So we will be discussing each method in the subsequent lectures.